Thank you very much. Good morning, everyone. I'm going to talk about Buildpacks. So before I start my presentation, I want to ask you, who is writing Docker files for production? Who is using Buildpacks? Only one. So that means all the others are in the right place, right? Awesome. So I'm going to tell you a little bit more about Buildpacks and why I think actually they're awesome and why you should use it in production. So I'm Patrick. I'm coming from Switzerland. There I'm like a technical agile coach. I help teams actually to get better on things and pushing better quality of software into production. And I love to build solutions with humans. And as well, I lecture at the University of Applied Sciences in Zurich as well. And I'm a little bit involved in the community, in software community in Switzerland as well. So I'm probably one of the 6 or 7 speakers actually from Switzerland at this event, which is amazing. Great. So I'm going to talk about what containers are, just a brief overview. Then we are jumping into Cloud Native Buildpacks. I'm telling you why Buildpacks are way better than Docker files. And in the end also I will give you some ideas how easy it is to use Buildpacks and why you actually should use them. From a security perspective, from a build perspective, and why actually they're so way better than if you would do it on your own. So that's actually the goal of the next 40 minutes we're going to talk about. So we know that containers were a great invention. And I would say containerizing applications and isolating applications and not just running them on VMs with other applications was quite helpful in the past. I mean, we are using Linux tools to create the containers. You know that containers contain of layers and we are adding things on top of that. And another thing about them, what I find quite interesting is they are super lightweight. They can be probably even more lightweight than the ones you have in production, because you could even have something like distroless, or you could even create your own containers from scratch, which means you barely have a layer from the distribution, from the Linux distribution in there, right? And we run applications through these containers in a cloud environment on Kubernetes, wherever you actually want to run them. So Cloud Native Buildpacks is actually a thing which will help me to create those containers. It's a Cloud Native Foundation project, and that means there is quite a lot of backing behind that. And of course, also there is a huge environment or a huge ecosystem around Buildpacks. So Buildpacks, it's not something new. It started in 2011. That's actually quite a long time ago. And from a cloud provider, from a platform as a service provider, you probably still remember, called Heroku. So they did that the first way of containerizing your application, because in Heroku you just said that's the path to my repository, and then actually Heroku took the source code and containerized it to run it afterwards for you. It was hidden for you behind the scenes, and that was actually already a great thing. And it helped them actually to move things easier around, and also for example, if you needed scaling and so on, it made their life so much easier, the containerization. A little bit later, where we got into the version 2 of the whole thing, Buildpacks were part of Cloud Foundry. You probably remember that. For me, it was around 2014, I got in touch with the technology, and I was surprised using CF pushing my source code actually to Cloud Foundry, and Cloud Foundry created a container for me in the platform. So I didn't have to do the container myself. I just pushed the source code, and then actually the platform built it the right way. And you see also in V2, we had kind of a similarity between Heroku and Pivotal Cloud Foundry. But then actually later in version 3, they got merged in a way, and they standardized the whole thing under the umbrella of Cloud Native Buildpacks and the CNCF. So that's basically where we are at the moment. Now, of course, for us developers, things have changed because of the adoption of OpenShift, not OpenShift, but OpenShift and Kubernetes. Because now we are actually using Buildpacks to build the containers not on the platform anymore, but we are using actually in the pipelines. So for example, if you use Spring Boot, then actually it's part in the Spring Boot Maven or Gradle plugin to build your containers from scratch. So things have changed a little bit since then. But what I wanted to say with this slide is basically it's a quite mature technology. It's out there for a long time, and it's really stable to create very nice containers in a reproducible way. But we'll get there a little bit later. Okay, so one of the implementations of Cloud Native Buildpacks is actually Paketo. And Paketo is awesome because it has like a solution for you for almost all the different technologies out there, and also like the ones on the slide. As you can see, from Java, from Cloud Native images, from Go, even .NET. If you think of like JavaScript and Node, for example, PHP, Ruby, static files like with an Apache server, and so on and so forth. Even Python is actually supported. So the great thing about the Buildpack is it can detect like what kind of project you have, and it will create for you the best container which is possible, right? Okay, so why are Cloud Native Buildpacks relevant today? So the thing is actually like it simplifies building container images without Docker files. If you write Docker files yourself, you need to know about infrastructure. You need to know about the containers. There is a lot to know about it. And there are so many bad examples in the internet because like lots of examples show like how your processes run, for example, with privileges. So just like search for some Docker files, and I'm sure we will find like plenty of issues in there. Another thing is actually like if you use Buildpacks, you have a consistent way across teams to actually like build the containers the same way. And I will talk about that point a little bit later as well. Then actually like somebody else is actually like maintaining the whole thing. Buildpack is a community, and that means like a lot of people are contributing. They're constantly updating things, so I just can leverage that without doing it myself, and always like keeping track of all the things I need to do in my Docker file. Another great topic is we have reproducible builds. So if you cache the things the right way in your pipeline, you can reuse layers. And Buildpacks are able to relink layers. As you know probably from Docker files, it's always like from the line where things have changed, you have to build like the other steps upwards. No, Buildpacks can do it differently. So if just like one layer has changed, they can relink the hashes, and then that means actually like there is no rebuilding for such a layer. And that layer can be like anywhere. It doesn't matter. It doesn't have to be even in the right order. We can actually like deal with that. And also, if you're building actually like with the same sources from Git, for example, with a Git hash, and with the same builder, you will have the exact same SHA for the container afterwards. So it's really reproducible. And that's very important these days to have like reproducible builds. And of course, it fits very smoothly into the modern DevOps workflow. And there are some examples, like for example, changing the run image underneath without changing the application which is installed can be done quite easily. So we'll get into that as well. So be aware of that Cloud Native Buildpacks and also the container images which are created are supported by many different things. So for example, we have the PaaS platform. So everywhere where you can run containers, you can also run these containers created, right? So that's basically like the regular thing. Then you have CI/CD tools which support it easily, just because of like having additional plugins or other things in there. And even, for example, local dev tools like, for example, Spring Boot, Maven or Gradle plugins, like other command line tools will help you also like with the developer support there. Buildpacks actually are also visible, and you see even like the layers created in container registries. So for example, if you go to Docker Hub, you usually see like how the Docker file would look like. But if you look at a container created by a Buildpack, then actually you would see like which layers are there. So actually those tools make this information also visible. So it's quite supported across the whole industry for all the different things. And I just tried to like add like some ideas, and I'm pretty sure you know many of those tools already. So I don't go like into the tools directly to show you how it looks like there and so on. That's not the idea of the talk. More the talk idea is about like telling you more about Buildpacks. But what I want to tell you is actually like the adoption is quite high, and basically like even Spring Boot, Quarkus, and others are supporting that thingy. So imagine you have your source code and you want to move into a production-ready container image. in a standardized way, and you don't want to write Docker files. And Buildpacks actually help you with that. And the great thing about this is, if you have multiple teams, you can use the same approach, exactly the same approach how to create containers. Because if you do Docker files, I'm pretty sure it doesn't look the same, right? So Cloud Native Buildpacks is a Cloud Native Foundation project, as I told you, and it comes actually like with 3 different specific artifacts, and they are mentioned here also like on the GitHub page. So basically, it's the CLI tool, which is called Pack. And that's like one implementation of the lifecycle. So the lifecycle is a library which even Spring Boot uses inside the Maven and the Gradle plugin to do all the steps needed to create those containers. And I will get into that a little bit later in my demo to show you how this looks like. And then, of course, we have the specification, because there are, besides Paketo, there are other vendors out there which provide you builders and tools around this. So the specification is as well important. So the 3 artifacts are very important. But besides that, as you can see, we have a community repo, we have an examples repo, we have some RFCs and so on. That means just like that's needed to like do the whole thing. So why should you choose Buildpacks instead of Docker files? Imagine your company has like N teams, and every team actually like works on 2 to 4 services. That means like the amount of Docker files are exploding. Imagine every team picks a different base image, a different JDK vendor, a different operating system in there. Some like Ubuntu, some like Alpine, some wants to have like distroless, for example. That means like it's exploding. You could say like 10 teams, 4 Docker files, right? I mean, that's already like 40 Docker files you have to maintain inside your company. Maybe it's even more. Think of 20 or 30 teams, for example. Or your team has maybe even more than 4 services. It's easily exploding up to like 100 different Docker files to maintain. So imagine now, one critical CVE pops up. In your pipeline, you have to like rebuild and retest the whole thing. And that means like you have to like redeploy every service. And that's quite a lot of effort actually. So having more a consistent approach where like everywhere everything looks the same is actually like way, way better. And it makes it like super simple actually like to handle. And knowing Buildpacks actually also like, and using an approach where you just can change the run image, and we have a tool for that, makes it so much easier actually. That means like you don't have to like run the pipeline for all those containers again. So in the end actually, if you use Docker files, you have more like an organizational problem than a technical problem at scale. Because like if you imagine that many teams, you get it from a blueprint how to do the Docker files, and everyone adjusts it a little bit. So that means like really like you have like 40, 80, 100 different Docker files in your organizations. Okay, so imagine you're a senior software developer. Imagine you know that if you're building an application and your container, and maybe that's not the best way how to do it, but even though you have heard of like multi-stage Docker files already, you are using like one stage actually like to build the application and then copy the files over. That's great. You maybe have heard of the thing that you should not use a privileged user to run your application. So that's why we are adding actually a user to the whole thing. Maybe you have heard of like that you should add health checks to it so that we get feedback actually like from the container when it started, right? When we know that the Java process is running. But there are still like things in there which are missing actually. And one thing actually like which is missing is like the Java memory calculator. Because like if you would use Buildpacks, there is a thing in there which sizes for you the heap in the right way. And that's actually amazing because sometimes it's quite difficult even for modern JVMs to find out like how much resources are available, right? You could prove or you could provide the XMX parameters from the outside. Yes, you can do that. But then if you change the resources, you have to change these XMX parameters as environment variables still manually. By adding, for example, like a memory calculator to that, and we'll see like what that means later, that job is done for you. What about updating your CA certificates? Have you created SBOM files? Because we are forced to do SBOM files soon, like for all the software we ship, right? What about actually like the signal handling? So for example, when you start with PID1, your Java process, your OOM killer actually like in Kubernetes cannot just easily send you a SIG term. It just will kill the process. That's also like very bad. This is not done actually like in here, right? So what I want to say here is, even though we think we know a lot about Docker files, we still make a lot of mistakes. And that's why somebody else should do that for us, somebody else who knows it even better. And I will tell you later a few things about Spring Boot applications and why you should do that as well. Another thing is actually like if you have Docker files, they're non-deterministic by design. So imagine if you install curl from a repository. Every time you install curl into your container, it might be a different version of it, right? We want to make sure that it's reproducible, but this way it's not. So also the latest tag on the Ubuntu is a problem because like the tags are moving in Docker, as we know, right? So this is a thing. And Buildpacks actually really helped me with that I create the same, with the same sources, I get like the same layers created. So that part is really, really reproducible. And even using like now the pack CLI on the last line, where I have like even a version added to my builder, I can pin it down and I can really like use the same builder and I will get an identical digest, an identical SHA for my container image which is created. So that's very important, especially also if you like consume open source and you want to check if that is on Docker Hub, for example, provided or in the Google Container Registry, it's the same as you would build it like locally. Because sometimes it's not and we just like trust others too much, right? So yeah, so we could try. Now imagine if you do the naive way and say like, I'm using the OpenJDK base image, for example, the image size is usually like way big. And actually, to be honest, we have at the moment around 200 CVEs in there. That's a huge attack vector, to be honest. If you're using something like a multi-stage build and you use like the Temurin JRE, you can slim it down a bit, right? And then you're around like 250 megabytes for your container, but you still have like around 40 to 80 CVEs in there because it uses a package manager inside. So you have maybe an Ubuntu, have a package manager, you have a terminal in there. So we have still like a big attack vector. You could use something like from Paketo, which is even smaller. It's the noble Java tiny thingy. So that means like only the dependencies to run Java are inside this base image, right? And that slims things down even more, but we still have actually like around 10-ish CVEs all the time because of bash, because of like compression algorithms and these kind of things. And you could even go a step further. If you say like, I'm using with Paketo a distroless builder where I don't have like a shell there, where I don't have a package manager, I only have the C libraries needed and the Java version installed, I can go down actually like to 0 CVEs. So this is actually like something awesome to know that. So we are faster, we are smaller, and also like we have a less attack vector actually like for our application, right? And that's actually like amazing if you could do that like with Buildpacks. So imagine you have something on the command line, and that's just the basic part, and I will show you like some advanced things a little bit later. You could use the pack CLI on the command line where you just say like pack builder suggest. And I can show you that shortly in my terminal. Here we go. So, and in my terminal, if we do this pack builder suggest, you will see like pack will tell you there are different builders out there which you could use. So I ran all the commands before I came here this morning just to make sure I don't have demo issues. And you have to trust me that I did not manipulate the terminal, right? But just like to do my demo a little bit faster, I just printed out those things. And you see like we have suggested builders for Google. We have things for Paketo Buildpacks. We have also like even UB8, UB9, and UB10 support for Red Hat in these Buildpacks. And there are like way more builders and Buildpacks out there. So this pack suggest or builder suggest will actually tell you what's kind of like part of the community, and you just could use one of those. Now switching back to my slides, here, I could do another thing. I could say like pack build, and I provide the name, and I say basically like use that builder in that certain specific folder. So imagine we are running this command in the folder, and then it just finds out how to build my container behind the scene. I can choose easily such a builder. If I do Spring Boot, it's just enough to use like Spring Boot build image as a command for Maven, and then actually like Maven would do that for you. Just that you know like how easy the whole thing becomes. You don't even have to install Pack because the lifecycle library is part of the Spring Boot Maven plugin. So if you do that for Spring Boot, and if you run the whole thing, your Spring Boot application, you will see there is here on the top, there is actually quite a little bit of output. And it doesn't matter like what's written there. This is the thing which is provided by the Buildpacks. You usually don't see that if you do it manually in a Docker file. But what it's done here is, for example, they calculate the memory for the heap, how we can like partition the heap. It installed, for example, the CA certificates in the Trustor from Java, which is installed. Then actually like it does some other things, like for example, exit out of memory error. So for example, if you do not have enough memory anymore, the Java process dies immediately so that Kubernetes can just like reschedule the container for you. It's quite amazing, actually. And there is some other monitoring and diagnostic options actually like added a little bit more below. Even what's quite interesting is, if you use the Spring Boot Maven plugin, and then behind the scenes the Spring Build Pack, is that like Spring Boot applications do not get installed into the container as a fat jar. They get unzipped by default, because it's faster to run an unzipped Spring Boot application than actually like running with java-jar from the command line. I'm not sure how many of you knew that. You don't need to know because the Buildpacks just do it for you, right? That's amazing. So there are many little things behind the scenes and what we would consider best practices, and the Buildpacks just do that for us. Imagine now you would add in your Docker file CA certificates. You probably would do that like this. You would copy the files in, you would run the key tool to install it into your CA certs, and you would copy the files over and so on. And I mean, if I look at this, I get eye cancer because like there are so many things in here which are so wrong. And just starting from the first part we have heard already, from OpenJDK has about 200 vulnerabilities. Then we run with a privileged user, for example. We don't have like the sizing for the heap, and so on and so forth, right? But that's like these examples you find in the internet, and that's super bad. It's also not exploded. It's the fat jar version, right? So bad again. So, but what I wanted to show you is actually like if I do that with Buildpacks, actually like I can also easily add CA certificates to my container. And that's something you only do when you have like self-signed certificates. Imagine in your company you probably have this as well, and you need to make sure to the regular CA certificates, yours need to be added as well. It can be done very easily. And fun fact here actually is, it doesn't matter what kind of technology you're using underneath. If you're doing the container for Node, for Python, for PHP, for Java, it stays the same. That's amazing for your platform team. They don't need to know like how to do the certain thing for a certain technology, not knowing about key tool and so on, but just like adding it, and then actually like the CA certificates get installed the right way, right? And for example, if I would see the output, how it works there, you see the 147 CA certificates added to the JVM Trustor. That's just mine I added because by default it's 146. So that's what I wanted to prove here, that it works. Great. So as I said already, it works for any kind of technology. You have the same approach to build containers across your stack. Now imagine your Buildpacks architecture. We have a build image, we have a run image. They were called stack before, they are not called stack anymore. Sometimes it's still used a little bit, so the word is kind of like deprecated. But the build image is meant actually like to do the steps to create the container. The run image is the base for running the container afterwards. So the build image is usually huge, like 1.5 gigabytes, to have all the build tools in there. And then you have the run image, which is quite tiny. For example, think of like 20 megabytes for an Alpine Linux or so. It's quite tiny. A build pack itself is like a step to manipulate the container created. So you can have many build packs to actually like manipulate your containers. The life cycle defines like which steps we are going through. And the builder is basically like a summary, a collection of everything. So by specifying the builder, you have like the build image, the run image, the build packs in there, and so on. So imagine your source code gets provided to your builder and the build packs are running. The build packs actually like have two steps, like a detection phase and a build phase. So they are going to check if we have a fetch jar there. If the fetch jar is there, we can run it from the command line, right? If it's a Spring Boot app, we can explode it, for example. That is what's going on there in the detection. And build packs will create in the end, after multiple steps, basically like your container image. There is a meta description for the whole thing. It's called like buildpack toml file. So you have some metadata in there. You can also like depend on or like say like you inherit basically like other build packs as well. Yeah, so that's the thing about that. So as I said before, we have the two steps. And depending on what kind of technology you're using, you're going to check for different things. Right? And that means like the detect phase is going to check if there is a certain artifact there, for example, or if certain like environment variables are provided and so on. And then actually like in the build phase, we are doing a certain thing, right? And that means, for example, for a Java application, there might be the JDK installed, there might be a JRE installed and so on, right? And sometimes even like you might need to build something like a Node application. You have to download the Node modules, for example, right? And that would actually like happen in there. So the phases actually like of these builders are analyze, detect, restore, build, and export. So the analyze phase actually like checks if we have already something there from previous runs. So that means like if it detects we have some caching there, that's actually awesome. But then actually like in the detect phase, we actually go and check if certain preconditions are done. Then actually like we have the restore phase. We have the build phase, and then actually in the end, the container is created. That's basically like the overall picture, how it looks like. So the builder is kind of like a collection of build packs, right? And also it contains like the run and the build image. So you can customize quite a lot of things actually like with build packs for your applications. If you want to, like for example, add your own certificates, if you want to add some license checks and so on, you could easily like write your own build packs if you want to. There is a registry, which is kind of like the official registry to see all available build packs. There are like hundreds out there for different vendors as well. Now, what I find quite interesting is if you have a CVE in your application, then you don't want to rebuild all hundreds of your application again. And that's why we have this rebase command where you just can replace the run image and you keep the part of your application as it is. So you're just like under the hood, you're just changing the run image without actually like rebuilding your application. And that happens or works because like the layers are linked or relinked easily, and we are not like in a Docker file where we have to build from the part where something has changed upwards everything else. Right, so that's actually like a quite neat trick and to be fast if you have vulnerabilities in production. So Paketo is actually awesome because like it has the hugest ecosystem. They come in 3 flavors: base, tiny, and static. So base has quite a lot of like tools in there, like for example OpenSSL, like things like C and C++ libraries and so on. The tiny one usually is made for a minimal footprint. So for example, that you only can run Java in there. Static is for static linked libraries. And also like if you would run, for example, something like a Tomcat or an Nginx in there. Right, so actually like we have a quite huge feature set here. Imagine also that they create by default an SBOM, so you can see like what's in there, and you can easily like extract those SBOMs created, because if you have a package manager inside your container, you can see like what's installed. The jars are visible, right? And you could even go down and say like if your application uses Node, you can see like your Node dependencies in there. So you exactly know what in your application is running. Great. So you could even like deal with instrumentation. If you want to like expose JMX, you can do that. By default, it's not enabled. That's a good thing in the cloud by default. If you use Spring Boot and the Spring Boot build pack actually like detects that the actuator is there, they will also use like health and metrics endpoint and so on. You can easily also like enable open telemetry features. There's that, for example, the open telemetry agent is added, and so on and so forth. There are like many different good things you can easily do. There are also some advanced features actually, which I like because you could, for example, choose the flavor of your Java version. You can actually define the Java version. You can also say, for example, that you want to have Spring Cloud bindings in there. So that means like enabling health and readiness checks, for example. And for example, as well, you could do something like JLink in your container. We'll see that a little bit later. And of course, it supports also like the Cloud Native images from the perspective of the Java buildpacks. Buildpacks usually use like environment variables to like configure things. The one without the L are meant actually like during build time. The one with L are meant like for lunchtime. So you're basically like adding additional parameters and things for your run container if the environment variable has an L in there. So these are just like the default ones that you get some idea like how that looks like. And we can provide, as you can see on the Docker command below, the launch parameters, even like as an environment variable. Good. So let's jump into the demo to shortly like show you how the whole thing works. And that means like I just jump into a very simple one. So I started to use the Buildpacks builder from Google here. And what it tells me actually is that the Google Builder has 6 build packs available, but it detected 5 of them which need to be executed. Because it's a Java Maven project, it actually says we need the Java runtime, we need Maven, we have a Spring Boot app, we need an entry point, and we need to label the container. And those 5 build packs are actually executed here. So you don't see much here, what's going on, just like in the builder step. You just see that like Maven is executed here, right? And there is some other things added. So the one thing line, you don't see a lot. And in the end, we have the export phase where it creates basically like the layers and adding the labels. And you even see here in my example here, it's reusing layers because I have been doing the build before. If I show you the whole thing like with a thing I did with Paketo, you will actually see what much more. Now in my case, with the pack CLI on the command line, so I'm using here pack build with the Paketo builder, it's actually like detecting 10 out of 26 build packs. And you see like what needs to be done here, right? And of course, Tomcat, Tommy E, Liberty, probably they don't get detected, hopefully not, because it's a Spring Boot app. So that's why. So just like the diszip is important, and the Spring Boot one as well, Maven, Sift for the BOM, Belsoft Liberica is the Java installation, and then the CA certificates. And if you go down here, you see like that it realizes some things actually like could be restored. Then you see like the steps, even with the configuration parameters. Now you see also then later that it's going to download depending on my Java version I used for like the jar file because it's written in the manifest which Java version can be used. It's downloading now the JDK 21. It's adding some other things to that. You see also like Sift for creating then the SBOM file, and it's running Maven here. It's the pack CLI, right? I do it from the command line, which is kind of weird because the Spring Boot app, I would do it differently. But that's the next code I show you. And then actually it's going to like say, we can actually run it with Java -jar because like it's in the manifest. And then it does some other things like Spring Boot related. And then it will start like unpack the things. It's installing like the Spring Cloud bindings. And then actually like it creates the container. And as you can see now, these are really like the steps as you have seen in my drawing before. Now the last one I want to show you is my Spring Boot build, right? That's just my Spring Boot app with the tests and so on. I'm doing that with the pet clinic. And let me go to the right place because like that's still the build, right? So I'm scrolling down. And we'll see like in a second, oh, so many tests are executed. Now we see that in the build image step, actually, we have now 6 out of 26 selected. Tommy E, Liberty, Maven is not needed anymore. And then actually like the same things happen. And now I need to check, yes, that's okay. Interestingly here is I did something where I needed to start the Spring Boot application inside here because I said actually like with a parameter, I want to have AOT caching enabled. So, or app CDS enabled. So if you want to speed up your application, you can set a flag, then it does a training run, it dumps an archive, and you can restore that from the archive afterwards. So in this case, like it uses AOT caching, you see that here, and it just runs the app, and then it dumps the thing. So if it's executed here, it still like runs the app, just like for a start, so that the dump can actually like happening. So it's happening here with the dump AOT caching. Then it stores everything into a file. It needs to change the system properties for starting the application. And then basically we can create a container out of that. So kind of it's magic, and you just could run it easily then from the command line. So I need to jump back to my slides to show you some other goodness. So imagine your company needs some custom fonts. They won't be installed in a container. I had a pet project, and I was looking for a emoji font, you know. An emoji font in a container doesn't make sense because it's waste for most of the application. So there is no emoji font inside an Ubuntu container, for example. So I had to add it myself. So what I do in the example is I inherit basically from the run image from my base container. I inherit from that and use like now apt-get to install something as I like that. So I can basically like add anything into my run container if I need that. That's super handy. In my case, emoji fonts. Okay. There are other things actually like you could easily do. You could add additional JVM tuning. You could think of like adding like agents and stuff like that for metrics and monitoring. You could actually like forcing checks against licensing, or like also forcing this way to like have a standardized way of logging configuration. And for example, Pack can do that easily on the command line with parameters. In Maven, you can easily add that as a Maven configuration inside the plugin. In Spring Boot, you just explain it like this. I'm going to use a specific builder, not just like the default one, right? So you could say like, I'm using my one, the one with the emoji font, for example, and it will use that instead of like the default one. If you want to do that with a distroless one, then actually like you can refer to your distroless one. And I've built one because I was curious, and I realized in the end it's not even a distroless, it's actually like one from scratch which just copies the C libraries into the Scratch containers and some things related to the time zone, and that's good enough to install afterwards Java and run it. And even for me, it's like reproducible, and even I have some things, goodness added regarding security in my GitHub setting. Great. So you can actually also choose other Java build packs because there are many out there, and you can use the ones you like. For example, if you want to use Semru, so you would use like the Eclipse OpenJ9 build pack if you want to have like some JVM installed which uses a little bit less resources regarding RAM. Who of you knows JLink? Nobody? I think that's probably like the underestimated tool in Java. And that's like the reason why they did modularization in Java, because you can choose which modules for your custom runtime can be used. So using just like that argument for this this BP, JVM, JLink enabled, and if you want to do even more, you can even like mention all the modules you want. You can shrink your installed JVM massively as well. So that's actually amazing. So that means like just the modules your application needs can be provided into the container. So that means I create a custom version of a JVM, right? In Java 25, actually, there is a thing regarding AOT caching. And AOT caching actually, and even AppCDS before 25, allows you to start from an archive. So that means like we saw the training run before, and that's just a mention for the AppCDS, and that's the AOT caching one. it just dumps actually like the classes you have loaded and some more information, and that means your application can start from there. So your JVM startup is way faster. It takes just a little bit more time to build your container because of the training run. You can easily like integrate your build packs into the CI/CD pipelines. So that means like choose the right build packs. You can like automate security scans. You will have the goodness of like reusing the optimized layers because of caching. So do the caching the right way. It's versioned and so on. And you can easily integrate also observability and metrics. Great. So just to summarize the whole thing, you really do not need Docker files actually, because like I think this is so much better and it provides you way more value because you don't need to know about all these infrastructure topics, right? You can focus on the application. And for the platform team, it's awesome because they can standardize the way containers are built in your organization to the same way. Build packs are always creating the same way, the containers, and you don't have like for every service a different Docker file, which actually is amazing. We also have seen that if CVEs are happening with the rebase, so with pack rebase, you can change, for example, like the run image easily. So that means you don't have to like rebuild everything all the time, which is also like quite amazing. Great. So that was my presentation. I would be happy to get some feedback from you. So please use the Devoxx companion app, provide me feedback, and we can also talk outside afterwards if you have questions during the break. If you want the slides and also some demo applications, you can use my QR code and you will find all those things on my GitHub repository. Thank you very much.